Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: Google is reportedly in advanced negotiations to have Samsung's foundry manufacture part of its next-generation TPU chips. This story goes straight to the heart of AI chip supply chain strategy, and it's more nuanced than most headlines suggest. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Think of it like a major car manufacturer deciding how to source the most critical components for its flagship electric vehicle. So sit back and enjoy. Let me use a car manufacturing analogy to frame this story. Imagine a popular electric vehicle maker that has long relied on a world-class, elite parts supplier to build the motor that powers their cars. This partnership has worked extremely well for years. But lately, the EV maker had a sobering realization. If we keep depending entirely on this one supplier and something goes wrong at their factory, a disaster, a fire, a shortage, we can't build our cars at all. So they reached out to a second, highly capable manufacturer and asked, could you handle the wiring module that connects the battery to the motor? Negotiations are now underway. This second manufacturer, Samsung in our analogy, isn't quite at the same level as the elite supplier when it comes to building the motor itself. But when it comes to the wiring module and the connection components, their skills are proven and reliable. The EV maker looked at the situation and concluded, for this particular part, we can trust them to deliver. That judgment call is the key to understanding this whole story. So why would the EV maker deliberately split the order, motor from supplier A, wiring module from supplier B, instead of keeping everything with one trusted partner? The number one reason is insurance. If supplier A's factory gets hit by a natural disaster or an unexpected production halt, having the connection components secured through a separate channel gives the manufacturer a fighting chance to recover. For a company selling vehicles at massive scale, a production line stoppage is absolutely catastrophic. In fact, in the automotive industry, sourcing the same component from multiple suppliers, what's called multi-sourcing, has been a golden rule for decades. Of course, there's also the leverage angle. When you're negotiating with supplier A, being able to say we're also in talks with supplier B can become a card that unlocks better pricing or better terms. And in this case, there are reports that the EV maker is also in conversations with a third manufacturer. The more options you hold, the stronger your insurance policy becomes. Having multiple credible alternatives isn't a luxury, it's a strategic asset. That said, having watched this industry for over 3 decades, I'd push back on anyone who tries to reduce this move to simple cost cutting. Building a structure where you can source from multiple manufacturers if needed has become fundamental business logic for companies operating at this scale. Let me now shift from the analogy and walk you through exactly how this plays out in the actual semiconductor industry. Let me summarize the EV manufacturer's stance: split sourcing, clear role separation, and backup options at every tier. Now, let's look at the real story. What was actually reported is that Google is in negotiations to diversify its manufacturing partners for a next-generation TPU codenamed IceFish, moving beyond TSMC to bring Samsung into the picture. TPU stands for Tensor Processing Unit. It's a custom processor that Google designs and develops specifically for AI services and machine learning workloads, optimized for the kind of matrix math that powers modern AI. And honestly, the logic Google is applying to its TPU supply chain is almost exactly the same as the EV manufacturer story I just walked you through. In the IceFish design, the roles are clearly defined. The main compute die, the core that handles the heavy AI calculations, will be manufactured using TSMC's most advanced process node. Meanwhile, the connection components linking the main die to HBM, or high bandwidth memory, are reportedly being negotiated with Samsung's 2nm process. HBM is the high-speed memory that AI chips depend on to process massive amounts of data quickly. The performance of those connection components has a significant impact on the chip's overall throughput. There's another piece to the story worth noting. MediaTek, a Taiwanese semiconductor company, is reportedly involved in the design of this TPU. MediaTek holds a top global market share in smartphone SoCs, system-on-chip designs, and is considered a serious engineering powerhouse. In this project, their involvement appears to be focused on I/O die design and back-end chip architecture, supporting Google's development work. The core compute logic is still Google-led. Having an external specialist involved in the design of a large-scale AI chip is not at all unusual. It's actually becoming standard practice. For Samsung, this deal carries enormous strategic weight. Samsung's foundry division, its contract manufacturing business, has been in a challenging position in recent years, struggling to keep pace with TSMC in the most advanced process nodes. If Samsung can successfully manufacture components for a high-profile product like Google's TPU using its 2-nanometer process, that becomes a powerful proof point for winning future customers. Landing Google is a reference win that could reshape Samsung's foundry narrative. To be clear about TSMC's position, TSMC is actively ramping its 2-nanometer, or N2 process into mass production, and is already developing the next-generation 1.4-nanometer, or A14 process beyond that. Google's decision to keep the main compute die at TSMC is unchanged. Samsung's role is limited to the connection components, a subset of the overall chip. So rather than framing this as Samsung and TSMC competing head-to-head on equal footing, it's more accurate to see it as a deliberate division of roles, with each foundry handling what it does best. Volume production is projected to begin as early as 2028. That's more than 2 years away, but in semiconductors, that timeline is not far at all. The development cycle from design through tape-out, prototyping, validation, and into full production is a long one. For Google specifically, the exploding demand for AI services makes it critical to accelerate next-generation chip readiness. Starting negotiations and design work today is the only way to hit a 2028 production target. Zooming out to the broader industry context, this move fits squarely into a larger trend: foundry diversification. Apple and NVIDIA are well known for their extremely high concentration of manufacturing at TSMC. Google, by contrast, has a track record of using multiple foundries across different products. With IceFish, Google appears to be extending that approach to its TPU line, potentially bringing in Samsung and Intel alongside TSMC as manufacturing partners. From my time on the factory floor, what stands out most to me about this move is the contingency mindset. Demand for AI semiconductors is expected to keep accelerating sharply, and the manufacturing capacity of leading-edge foundries like TSMC is being fought over by every major tech company on the planet. In that environment, Google not having a backup plan if TSMC's allocation falls short would be a genuine management failure. Contingency planning at the chip supply level is no longer optional. It's table stakes. The pricing leverage angle is real too, and I won't dismiss it entirely. Maintaining active negotiations with multiple suppliers does reduce the risk of any single vendor holding all the pricing power. That said, given that Google is continuing to concentrate its main compute die at TSMC, I read risk diversification as the primary driver here, not cost optimization. The fact that Google is keeping Intel in the conversation alongside Samsung reinforces that interpretation. This is about optionality, not discounts. On Samsung's 2-nanometer process specifically, yield data, the percentage of chips that come out of production working correctly, is not publicly disclosed at this point in time. But for connection components, which carry comparatively less logic complexity than a full compute die, there's a reasonable case that Samsung's 2-nanometer capabilities are well suited to the task. How Samsung performs during the production ramp will be one of the key things to watch as this story develops. Let me also elaborate on MediaTek's design role. Based on what's been reported, MediaTek is supporting Google on the I/O die and back-end architectural design, the parts of the chip that handle data flow between the compute die and the rest of the system. Google retains full control of the core compute design. MediaTek is acting as a design partner for the surrounding architecture. AI chip design is extraordinarily complex. It requires deep expertise in specialized compute circuits and in chiplet integration, where multiple dies are combined into a single package. Bringing in an external partner with specific skills in these areas is a well-established approach for large AI chip programs.
Let me pull the key threads together. Google is in negotiations to manufacture its next-generation TPU, codenamed IceFish, with the main compute die going to TSMC and the HBM connection components going to Samsung's 2-nanometer process. MediaTek is involved in design support. Volume production is targeted for as early as 2028. For Samsung, this is a high-stakes opportunity to establish a 2-nanometer track record with a marquee customer. For Google, the primary goal is supply chain diversification and risk mitigation. Google has a history of using multiple foundries across its product portfolio, and with IceFish, it's extending that approach to its TPU line, bringing TSMC, Samsung, and potentially Intel into the picture. The way Google is constructing this multi-foundry strategy deserves serious attention as a template for how AI-era chip procurement may evolve.
Let me give you my bottom line. The real story here isn't about price, it's about insurance. The configuration where TSMC handles the main compute die while Samsung takes the connection components isn't a head-to-head competition. It's a carefully designed risk management structure with clearly separated roles. In the AI era, Google's investment in its own custom silicon is directly tied to the competitiveness of its cloud services. Concentrating the entire manufacturing of that silicon in a single location is an unacceptable risk at this business scale. I expect this pattern of distributed sourcing to spread to other major tech companies as AI chip demand continues to accelerate. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.